Okay, so for this problem, we have 5 different properties to verify. Each of them come in 2 different forms, basically, if we swap the multiplication and addition here. Looks like we get equivalent forms of all of these different things. So we're just going to focus on this first one, 9a, and try to prove these equations. So we have x plus, we're starting down here, x plus x times y equals x. And we're going to be using these same properties. So again, look over here at our properties of Boolean algebra. And we're just going to use these to try to transform this this equation into a tautology, into something where both sides are equal. And that generally means to simplify the left-hand side. So if we're starting with this, the first thing we can do is kind of a common trick for a lot of these problems. If we can turn something here into a form of 1, or rather if we can sort of put something in using one of the properties that doesn't do anything, like multiplying by 1 or adding 0. And so in this case, we're going to take this x at the beginning and multiply it by 1, which is something that we should be free to do. Multiplying something by 1 doesn't change what it is, which is true generally in algebra, but we do need to be careful here. We're talking about specifically this property of Boolean algebra, multiplying by 1, we get x. So by the identity property, we're able to do this. And the alternative to this, I guess the one other direction you could try to go with this, looking at it, is this is kind of set up like the first problem, where we could think of this like a distribution, like this would turn into x plus x times x plus y. And you could try that, but it doesn't really get you anywhere. It just kind of actually ends up being this other statement we have up here. So it doesn't really help for this particular problem. So we're going to change this form so that we have x times 1. And then we're going to use a distribution property, but sort of in the other direction. So now we have x times 1 plus x times y. So we're going to sort of factor the y out of both of those terms. And if we look at what we have here, we have x times 1 plus y. And to make it more obvious, if you went through and distributed this, x times 1 plus x times y is what we're going to end up with. So this should be the correct form going in the other direction. And the basic purpose for that is to try to get this y combined with 1, because we don't really have any idea what y is. And if we look over on the right-hand side of the equation, we need to get rid of the y. So by getting this in this form where we have 1 plus y, now let's take a look back over here again. 1 plus anything, according to this universal bound property, 1 plus anything is 1. So if we have 1 plus y, then that should just be the same as 1. So using the universal bound property, 1 plus y turns into this 1 right here. So now we have x times 1 equals x, which seems pretty much finished at this point. But now let's just look back one more time at these properties. Anything times 1, where is it here? Anything times 1 is itself by the identity property. And this is actually the first thing we use. So we're going to use this same property that we used originally again, but this time to get rid of the 1 instead of to put it in there. And we have our proof that x equals x. And so this equation is verified. And so we have the properties that we're using along the way there. And then we'll just go through quickly the other direction, doing it with x times x plus y equals x. So we're going to start with that. X times x plus y equals x. This time, instead of turning this into x times 1, because we actually want them the same way we did here, where we had a product plus another product. In this case, we want it the other way around. We want a sum times another sum to use the other distribution property. So if we turn this into x plus 0 times x plus y is the same as what we had originally. We want x plus 0 instead of x plus 1, because x plus 0 is actually, again, we look over here, x plus 0 is x. That would be the identity property if we're talking about addition. So when we put in x plus 0, now we can do the exact same step. We're really just following the exact same steps here, except using the opposite properties for the opposite operations at each step. Whoops. So now we have, let's see, where am I? We have x plus 0 times x plus y turns into, well, the x plus 0 part just turns into x by our, oh no, I'm going backwards. The x turned into this. But now we are using the distributive property to say that this is the same as x plus 0 times y. And again, to make that more obvious, if we go in the opposite direction, if we take x plus 0, we get our first factor there. And if we take x plus y, we get our second factor there. And then we're multiplying in the middle. And again, this looks a little strange because this doesn't make sense according to the usual rules of algebra. But in Boolean algebra, this is valid. Just like it is for multiplication. So then finally do, again, following the same exact steps we had here, but using the other sort of properties for the other operation. We can turn 0 times y into 0 because 0 times anything is 0, and then 0 plus x. Going back one more time to these properties, 0 plus x is always going to be x, or rather, if you add 0 to something, you just get the same thing, and so 0 plus x would return back to x. And so there we have both of those equations verified.